Okay, so our names are Dhruv, Jay, Grace, and Kadir, and our project is OASYS, or Optimization of Airfoil Systems.
So what is an airfoil? An airfoil is like the cross-section shape of the wing, and our program is designed to take in inputs from the user, such as velocity, density, and Reynolds number, and calculate the optimal airfoil number, or the NACA value, and angle of attack, and also the highest possible lift-drag ratio.
Okay, so this is our program. It's called OASYS, like we just said. So this is the main page. Here you can adjust the Reynolds number, the density of the air, and the velocity. If you're interested in creating your own if you're interested in creating your own airfoil, here you can set all your own values. For example, 40, 40, and 12, and 200 points. Um, and essentially, this is the NACA value we were talking about earlier. So if we update the plot, this is the actual plot that this is the shape of the airfoil scene. So reset values. And now let's show the output. Let's optimize an airfoil to have let's maximize the lift and minimize the drag for an airfoil in this kind of environment. So now we're going to create a unique airfoil with those four values, and it'll be displayed as an NACA number. So that'll be here. So that's going to take a while to run. So while that's running, I'll go through the code. So first of all, let's talk about optimize.py. So essentially what this does is this is the code to optimize the lift drag ratio of the airfoil and minimize the drag. So what essentially how this works is we have a preset of NACA values, and then we get the coefficient of lift and drag by simulating them with Xfoil. I'll get back to those in a second. And then we use this function to get the best airfoil and maximize them using NumPy arrays. And now Kadir can talk about the GUI how we coded the
So
GUI.
we used PyQt5 for our GUI, and the majority of the code is just elements for the GUI. We have sliders, we have buttons, we have images, we have text, and so this code is just basically all about plugging in the values to the optimize function or optimize class, which is the class that does most of the operations. So if you scroll through all this, you can see that there's not much to look at in the mathematical or physical side, but it's just a lot of repetitive front-end programming.
Okay, so now let's go back to the NACA values that we finally calculated. So these are the optimized NACA values that we finally calculated for the optimal. So this is optimizing lifted drag at these values. So the optimal angle of attack at this given velocity is 8, meaning this would be 8 degrees facing upwards. The optimal NACA airfoil is 6409. Essentially, this means the optimal camber is 60. The percent camber is the location is 40, and the thickness is 0.9. The best lift to drag ratio here, and this is the lift to drag ratio of this airfoil, is 194 lift to drag. Is I think that should.
Thank you for listening to our presentation.
Thank
Thank
you.
you.